So each one of these is going to be kind of a little example of a scatter plot. Now, I'm going to go through, there's 3 things that you would use to when you look at your data to decide, okay, what model am I using? So it's called direction, form, and strength. All right, so the first one, this little row, is to emulate the direction. So what kind of shape do you, like this first little scatter plot, like would you tell me that was like a line, a parabola, exponential? What would you tell me? Like what shape graph would maybe estimate that data the best? Does it look like a U? Does it look like a line? Or does it look like exponential growth or decay? What do you think? What do you think? Probably a line, right? This I would say is linear. Okay. Now, the direction, though, this would probably be estimated with a line. The direction is basically like the slope of the line. So would that line have a slope that would be positive or negative? Negative. Okay, so this would be negative here. Now, let me just, I'm not going to draw a scatter plot, but let me just sketch you a picture of kind of like the shape the data would take. If you had a quadratic, I'm just going to write quad here, the scatter plot would kind of form like an upside down parabola in the negative direction. If you had an exponential function that had a negative direction, it would look like exponential decay. So if you had kind of like that backwards J-shape look to your data, then we would use an exponential model. Now, the one on this guy here, this is meant to be a scatter plot to do a linear here again. And this would have a positive slope, right? So the direction here would be positive. And just to give you like, I'm not going to draw a scatter plot, but if we had a quadratic that was, actually you can look right below here. If we had a quadratic that had a positive shape, it would look like this scatter plot right here, be a right side up U shape. If you had an exponential that had a positive shape, it would be exponential growth. So it would look something maybe like this on your scatter plot. Okay, now that's direction. The second thing is the form. And those are just the 3 different types I just mentioned. Does it look like it's a line? Does it look like it's a parabola? Does it look like exponential growth or decay? So then obviously like a line, you could also have one that went with a negative direction there. For a quadratic, you could have the negative direction would be upside down. And then for an exponential, would go that direction, but with a scatter plot. It wouldn't be an exact parabola, line, or exponential model, but with a scatter plot, but they can take a couple different shapes. Okay, now the last thing you're going to talk about is basically the strength of your model in comparison to the data. Now all of these examples here are probably linear if you look at them. So the strength here, like if you had a scatter plot that looked like this is, I mean, this is definitely a line, right? I could draw a line like right on that data and it would match up with every single piece. That would be really strong. Okay, what we call moderately strong, this is, I mean, I could still draw a line, like I can tell that that would have a positive slope, or even this data, I could tell this has a negative slope, and it has kind of a linear form, but the little dots are not quite close to being as tightly together as the one we just looked at. Now, my next little box, again, I could probably argue that I could kind of draw a line with a positive slope through that, or a negative slope through this example here. But again, as we go through this little table, these dots are spreading much further apart. Like they're not quite as close together as the one before, and they're definitely not as close as the first one. But they're still, I could argue that that would be a line. Now, this right here, this I would actually even say weak to I wouldn't argue that's a line. That's just like a blob of dots. Like I couldn't really draw a line through that and argue a slope one way or the other for the direction in that case. So I would actually say that's actually probably really not too much of a set where I would fit a line to it. So we're going to look at these underneath here, and it's related to what we call the correlation coefficient. Okay, the correlation coefficient, they're going to use the letter R in the calculator to represent this. This is the typical variable for this. And this correlation coefficient is going to show the strength of your model. Like whatever, if you decide it's a line, if you decide it's a quadratic, if you decide it's an exponential, this is going to kind of relate how strong it is. Now, the thing that's a little bit weird about this, the R value, I'm going to write -1 is less than or equal to R is less than or equal to 1. So the R value, the correlation coefficient, can be any number between -1 and 1. If the R value, basically, the closer to 1, the stronger positive it will be. And closer to -1, stronger negative would be the direction. And so I kind of put some R values here for you guys to kind of look at this. So if I had this data set, and your calculator will show you this value, you're not going to calculate this by hand or anything like that. So the calculator will give you these values. But if it's like a perfect 1.0, this is perfect, and the direction here would be positive because it's +1. If it was -1, it would look exactly like that, but have a negative slope, and the R value could be -1. Now, you guys can see here, this is positive, this is 0.8. We would call this strong positive. Like there's a strong correlation between those data values, and pretty much anything like 0.8 or above is going to really be a good estimate of your data. When you start getting into this area, like a 0.4, again, I could still kind of argue that this looks like it has a positive slope, but obviously this is a lot weaker in terms of representing the data. So this would be considered a weak positive. This one in the middle, the R value, it says is 0. So if the R value is 0, it's just nothing. This is just like a blob. There is no correlation there. There's no best fit for the data at all if your R value is 0. A line would not estimate that well at all if I tried to do that. Then the only difference here, these just have a negative R value. So that just means the direction is just going to the other side. It's still, the strength would be the same, it's just negative instead. So this one would be a weak negative, and then this one would be a strong negative with a -0.8. And I didn't write the perfect one, but if we had a perfect line like we did on this one, we could have a -1, and that would give us a perfect negative. Okay, now I'm just going to say, just see if you could kind of estimate the R value for the scatter plot that we have here. So remember, if it's positive, that means the direction of the slope would be positive. If it's negative, that means the direction would go and have like a negative slope. So just take a second and look at these graphs. And maybe just think, like, if I put a line to this, would the slope be positive or negative? Because that can help you pick out the R value. And I do have one that says 0. Does anybody know which one would be 0? Which graph? What do you think? B. This one, like, all over the place. There's no way you could draw a line for that. All right. Now, let me see the numbers we've got here. I've got a 0.88 and I have a 0.8. So we're going to have two that look pretty strong. The closer you are to +1 or -1, the stronger it is. So let's find the positive. I would say, right, this has a positive slope. This has a positive slope. This is almost horizontal, but I think that's a positive slope there. This one's negative, and this one's negative. And then B, nothing, because it's just a blob. Okay, so of the positive ones, which one would you maybe associate with the 0.88? For sure. Okay, which one maybe a little less, but still pretty good? So we use C and we use B. Which one still is positive? Pretty tight together, but not quite as tight as the dots on letter C. Which one would you pick? What do you think? Yes. Okay. Now, let me look at, we got two negatives, right? One at the beginning and one at the end. So the two negative R values I've got negative 0.92 and I've got negative 0.61. Which one of the negative graphs do you think go with the negative 0.92? F, for sure. All right, so then the other one, this is, the dots are much looser, so I would say that one would be A. It's still negative. It would definitely decently argue a line, but it's not nearly as the data points are as tight together. And then this is, these are not exactly loose, but it's not exactly super positive either, so this one would be D, that 0.275. Is anybody having a question? Okay, I'm going to run through with you guys how to put data into the calculator here, and it's going to take a second to do it. So if you want to get out your graphing calculator, I'm going to use the data. There's some kind of screenshots just to kind of show you what you're going to kind of see as you go through here. But I'm going to use the data that is in this lovely table here. It's this consumer price index for the housing market here. And I know this data is kind of old because it has the years from 1990 to 2007. What I'm going to do here, I'm going to let X be years since 1990. And they do this a lot of the time if you have a year in the data value, just so they don't have to type out like 1990, 1995, whatever. So I'm just going to kind of reorchestrate this data with smaller numbers. So if I do years since 1990, for 1990, I would just use 0, right? Because that is years since 1990, that is the year, so 0. So 1995 would be 5 years later, so I'll just use an X value of 5. 2000 would be 10, and then 2002 would be 12, and the rest of these just go by 1, so like 13, 14, 15, 16, 17. Okay, now before we put the data in, I'm going to have you do two things for me because it just depends on your calculator. If you're borrowing one of mine, somebody's probably already done this, but just in case. All right, you're going to we're going to turn the R value on. So the correlation coefficient is not defaulted to be on. So where am I going to write this? You're going to hit second, and then you're going to hit the 0 key. And that function on there is the actual catalog for the calculator. So just hit second and the number 0. And I know this is super weird, but I don't know a faster way to get here. This is literally everything that is in the calculator. Okay, I want to turn something on that says diagnostic on. When you're in this menu, it'll make the keys do the alpha buttons. So once you hit the 0, hit the button. It's like an X to the -1. If you guys see that, that'll take you down to the menu where it starts with the letter D. You are looking for diagnostic on. So you have to scroll down with the arrow keys just a little bit. And once you do this, you don't have to go back in and do it ever again. We just want to literally just hit enter twice. Make sure you're on the diagnostic on and not the diagnostic off. So just diagnostic on, just hit that twice, and it'll come back, it'll say diagnostic on and done. And then we don't have to do anything else there, but we have to do that before we start. Okay, the other thing I'm going to have you do real quick is hit the Y equals button. And I don't know if you have anything. If you have anything in here, that's fine. But what I need to have to do a scatter plot is we have to turn the plot on. So all you have to do that, and if yours is already done, maybe you don't need to, you need a black background around the word that says plot 1. So if you don't have it, just arrow up to that, just hit enter, and arrow away from it, just so it's highlighted. And if you want to go back in and turn it off, it's just that easy. Just arrow up, hit enter, arrow away. If you want it on, you want a black background around that word, because we're going to make a scatter plot. Okay, anybody not seeing those buttons or having a problem with that? Okay, now you've used this menu earlier in this unit when we did the stats for like mean, median, mode, that kind of stuff. You're just going to hit the stat button, and we turned the plot on already. So we're going to go ahead and hit stat, and then we're going to edit. And you might have some data in here already, so don't use the delete key. Arrow up to the top of the list. So it's highlighted, hit clear, hit enter, and it'll wipe out the whole column. Arrow up to the top, hit clear, hit enter, wipe out the whole column. All right, now, don't do this, but if you accidentally, let's say you use the delete key, and your columns do not start with list 1. You have to have them start with list 1. If they don't, just do this real quick. That stat button, that 5th option is like a reset for this. So if you accidentally delete one of the columns, just stat number 5, just hit enter twice, and then when you go back into edit, it should restore anything you maybe accidentally deleted, but it has to be list 1, list 2. Otherwise, we're going to have to mess around with a bunch of other settings. Now, in the list 1, you're going to put your X values. So I'm just doing those years that I renumbered so we didn't have to type the whole year in. So like the 0, 5, 10, 12. In between each one, you have to hit enter. Once you put those numbers to represent the years in, just use the right arrow key and get into the second column. And that's where you want to put your Y values. So list 1, you want to put X. List 2, we're going to put the Y values. And that's that consumer price index. Whoa, sorry. And just be careful as you do these. Each one of these, sorry, has a decimal place to it. So just make sure you hit the decimal. And I'm just kind of double checking, make sure I didn't mistype anything here. Okay, anybody need a little bit more time? Okay, once you have the data in, this is what you're going to hit. You're going to hit zoom, which is right in the middle of that top row, and then you're going to pick number 9. You can just type the number 9. It says zoom stat, and so what that'll do is it'll show you a graph of those data values the best it can, and that way we can kind of get an idea of the shape of the graph. So if you guys had to pick, would you tell me that looks like a line? Does that look like a parabola? Or does that look like exponential growth or decay? A line, right? Okay, now here's how you, once you decide that, so we're saying like, okay, we're thinking this is a line, right? Now, we're just gonna keep going following these directions down here. Now, forgive, this was just to show you what it looks like, but this is not for this data. It's literally just an example. I probably should take it off, but that's what the screen will look like when we get to it, but it's not actually the numbers are not gonna match the screen. Okay, now, I am not gonna have you guys worry about this or this. So here's all we're gonna do. We're just gonna hit stat and then arrow over to the calc menu. So we've used this before for the mean, median, mode, five number summary. But instead, what we want to do here is we want to find a linear model for our data. So if you think it's linear, it's going to be number 4. It'll say LINREG, like linreg. It stands for linear regression. So if you think it's a line, that's the one you want. So you can type the number 4 or arrow down to it and just keep hitting enter until the linear regression shows up. And then, does anybody's not display the R value? That's what we did the diagnostic on. If we hadn't done that, that wouldn't be on there. So the correlation coefficient is the very last thing right there. And you can see it's 0.995. So that means a line is a really good representation. It's almost close to +1. So it's almost perfect, but it's not quite. So 0.9954, that's a really, really good estimation. So a line was the correct choice here. To actually write the regression, and this is the only one that's a little weird, so you've got, instead of mx plus b, they write it as ax plus b. So my actual equation that we could use to represent this data, basically the a is your slope. So I'm just going to go like, let me just go 3 decimal places. So I'm going to go 4.694, and then I would put the x. So you'd put the y and the x in, you're just going to replace the a and b with the values that they tell you. and then your B would be your y-intercept. So I'm just going to go 3 decimal places. So let's go 656. And I don't think it asks you to do this, but a lot of the questions will ask you to like use the model to predict, in this case, the housing consumer price index for years down the line or something like that. But that's all you have to do. This would be an excellent model for the data. Let me write down that R value just real quick. I'm going to go 4 decimal places on this just because it's so close to 1, just to see it's not perfect, but it's pretty darn close. So this is a very, very strong positive correlation here between these data values. Is anybody having a question at the moment? Okay, now let me look at these real quick. Let me have you guys do this next one. All right, so I'm just going to go back in. We're just going to practice this one more time. Different data set. So I'm going to just hit stat. So we're just going to do stat, and then you're going to hit enter because you're just going to edit the list, right? And then in L1, you want to type your X values. In list 2, you want to type your Y values. So if you want to clear it out, don't forget, do not hit the delete key here. Arrow up to the top, hit clear, hit enter, it'll wipe out the whole column. Arrow up to the top, hit clear, hit enter, wipe out the whole column. Now, this does not have a situation or anything attached to it. This is just data, so we're going to look at this. I've got like 4, 6, 8, 12. Just typing these in. You got to hit enter in between each one. Just type the left side of the table in that first column, and then we'll type the right side of the table into the second column. And for the numbers that have, like, I have a 21,000, don't need to type the comma in, just type the digits for the number. Okay, now, after you do this, you're going to do zoom and then number 9, so you can decide what kind of a model do we want to use here. So just hit zoom and then number 9. And you can also look at the table to do this if you want to. What kind of a shape do you guys think that's going to take? Is that a line? Like I've got kind of data along here and then I jump up. What kind of a model would you pick for that one? Linear, quadratic, exponential. Yeah, for sure. Because it makes that jumps up really quick. You guys can see this in the data. Like this is getting really big really fast. So this is exponential growth right here. All right, so I'm just going to circle. That's the one we're going to pick. Now, to get this, we're going to do the exact same thing we just did. So after you pick your thing, you're going to hit Stat, arrow over to the Calc menu. Now, the only difference here, we don't want the line. We want the exponential. And you can, probably, maybe, it depends on your calculator. The exponential is actually right underneath number 9 here. It'll say EXP and then reg for exponential regression, but it's like way down. You can actually type the number 0 if you want to, but it's way down the list. So that's your exponential reg. It says EXP REG. And then once you either are down there or you hit the 0, just keep hitting enter till it shows up. And again, this is going to give you a model that will fit the data, and you can see the R value here is super strong. This is almost 1. It's 0.9996, like right there. That's a really strong, so this is a really good prediction of this data. Now, in terms of the best fit, so exponential is y equals AB to the x, and that's the exact format that they put it in the calculator. So I'm just going to go 3 decimal places again here. So I'm going to say y equals 2.099 is our A. And then don't multiply these together. Remember, keep them separate. The B value, I'm going to do the same thing. I'll go 3 decimal places. 1.495. And then to the X. Now, what's the correlation coefficient? Again, it doesn't tell you what to round to. I'm just going to write out several decimal places here to show you that it's not exactly equal to 1. We are a little bit off, but it's pretty darn. You got 4 9s. like maybe 653. I'll just write a couple of those, but you can see that's really strong. So this is a strong positive. Almost perfect, but not quite. So this would be a very excellent representation of your data. Now this is the thing that I wanted to have you guys look at. Most of these questions will ask you to use your model to make a prediction about another value in the regression. So this one, and I tried to pick numbers that would kind of fall into the table that you have, so that way you could kind of see if your answer makes sense. So 25 would kind of go in between the 23 and the 30 there on the table, right? Literally, all you have to do, we're just going to plug 25 into that equation. That's all we're going to do. So I'm just going to type 2.009 times 1.495 to the x, and we're just going to substitute 25 in for that. So that's all we're going to do. 2.099. I'm just going to type it exactly like I wrote it on there. And that way you guys can kind of see, does that number kind of fall where you think, like, does that seem outrageous, or does that make sense for what the y values are in the table? So here's your prediction. I got 48,757 point, I'll just write it all out, 5927. So see if that makes sense that that would fall in there. To me, that seems pretty reasonable. If we'd gotten like 700,000 or something, I'd be like, whoa, I screwed something up. So just so you can check. All right, is anybody having a question at the moment? All right, I'm going to skip this one because this one is linear, and we just did linear with that consumer price index for the houses. So this last one, and this is going to be a little bit trickier to see on the graph, but and just because it has negative x values doesn't mean this is quadratic, but here's the deal with this. Do you guys see, like, this is 90, and then it goes down to 46, and then it goes down to 3, and then at 3, it goes up to 361, and then it goes up, and then it goes up. This is going to be kind of hard to see on the graph. I should have given us a little bit more data. But this is actually, on one side, it's decreasing, and then it starts to increase. So this should create a quadratic. It's just going to be kind of hard to see on the graph. So I'm going to do the same thing. I'm going to enter the data, just stat, enter. So stat, enter, and then list 1, you type your x, list 2, you type your y, but you got to clear out what you got in there. First, just arrow up to the top, hit clear, enter. Now, when you do a negative value, if you get a negative data value, you have to use the negative key under the 3. Don't use the subtraction sign. The calculator will be like, that's not cool, and it will tell you it's an error. So just be careful with that. All right, and then I'm just trying to get you guys used to plugging this in. So you enter your data, then you're going to hit, I already kind of told you this is going to be quadratic, but zoom number 9. And it's a little bit hard to see, but these little dots here are starting to go back up. So this is going to make a U shape. It's just really wide. Once you decide that, decide if it's quadratic, exponential, or linear, then you're going to do stat, calc. This one on that list is going to be number 5. It says quadreg for quadratic regression because we're going to make a parabola. So stat, calc, and you can arrow down to it or you can just type the number 5. And then just keep hitting enter till it shows up. Some people get to it faster than others. Now, this will be in the format, just our standard form, so y equals ax squared plus bx plus c. So you got to sub in the numbers they give you for a, b, and c for your equation. Now, sorry, this line is probably not very long, but I'm going to write y equals, we got about 2.581, that'd be x squared. Now, the b value is negative, so it just means you just write minus instead of plus in between these terms, no big deal. So I'm going to say 5.267x, and then my c value is your constant, so no x with this, so plus 10.115. I'm just doing 3 decimal places here. Now, this is the one that's just a slight bit annoying, and I don't know why it does this, and I don't know how to change it, and I've Googled it a million times, and there's no reason for this. All right, so for the quadratic, you'll notice I don't have an R value. There is a capital R, and it's squared. Now, what this is, that R squared, what we're going to do to get R, we're going to take the square root of that number to get our correlation coefficient. Now, the super tricky part here, you guys can see that that's a really long decimal, that I would round that to 1, but we can't do that to get our answer. So what I want to just write out as many decimals as you can. I'm just going to jot them down here real quick. So it's like, I've got 4 9s, 620,096. I'm going to take the square root of that, and that is going to be our R value. So I'm going to just hit my square root key, 4 9s, 620,096, and take the square root. So it's sort of similar to taking the square root of 1 because it's so close to 1, so it's very close to 1 when I get my answer here. So I'm going to write out, you can write as many decimal places as you want. I'm just going to write several here. I'm going to write till they get to the zeros. So it's not exactly 1, but it's pretty close. Now, the other thing you have to remember, when you take a square root, we could do plus or minus, right? So let me go back. I'm just going to go to that zoom 9 real quick to look at the graph. Would this parabola be right side up or upside down? Right, this would be a U shape here. So we're going to go with the plus. If you had your data and it was making an upside down parabola shape, you would have to introduce a negative on that R value, just to be careful. The only one you have to worry about this with is if your data is quadratic. Otherwise, it'll tell you the R value. Now, this is very strong positive, almost perfect, not quite, but that just means the model is a super good representation of the data. And then, again, a lot of these questions will ask you just as the last part, what would your Y value be if X was a certain number, in this case 20. So again, I tried to pick a number that would kind of fall into the table so you can kind of make a guess as to whether or not this would be reasonable. So I'm just using the equation. I'm going to type that 2.581, and then we're going to just plug in 20. Don't forget to square it because this is a quadratic. And then minus 5.267 times 20. No, don't square that one, that's just X. And then plus 10.115. And we should get like 937.175. And just looking at that table, like where that would fall, I think that's totally reasonable to fall in that area. Just make sure that it makes kind of sense with your table.